Human decision-making is often flawed. Our assumptions, biases, and fixed mindsets limit our ability to solve problems and where to look for them. But with evolutionary AI, we can overcome these shortcomings to create the best possible decision strategy, one that considers past experience and adapts and improves over time. This evolutionary process starts by identifying real-world data that is relevant to a decision. We call this input context. Next, we must ascertain the universe of possible actions. And then, most importantly, we must pinpoint the measurable outcomes of a decision. Using all of this data, we create digital twins. These surrogates model the real world and enable us to quickly and safely generate viable prescriptive solutions to complex problems that we can then apply back into our businesses. For example, let's say you own a store and you want to put products on the shelves that will maximize your revenue, minimize your inventory, and reduce your resource costs. To optimize all three outcomes, you'd use relevant point-of-sale and shopper data to create a digital twin model of all possible product scenarios. Based on those inputs, and using evolutionary optimization, the best product placement strategies are then produced. These strategies prescribe decisions for various real-world scenarios that achieve the desired balance of revenue, inventory, and cost. Why is evolutionary AI so important? Because the traditional processes we use to arrive at desired business outcomes rely on statistics reflecting a static state of the system and ignore ongoing decision dynamics and feedback. And they are often modeled by assuming linear relationships between the data and the outcomes, even though such dynamics can have significant nonlinearities. Surrogate-based evolutionary AI is a closed-loop process based on feedback systems that prescribe and implement changes from the real world. So, once the computation is complete, new real-world data is collected to build the next generation of digital twins. And the predictive and evolutionary-based prescriptive models exploit nonlinear relationships to optimize outcomes. Let's look at a real-world use case that takes us a bit deeper into the two models. You want to create new prescriptive tests for application development. Each test is characterized by its type and variation, and against each test characteristic, you have a set of historical application descriptions that detail development costs, speed, and quality to create neural network surrogates. For the prescriptive model, we create an optimal test description based on the application data by using neural evolutionary computing to organically grow the prescriptive neural networks. With the cost, speed, and quality predictions of the surrogate model, we can test for the effectiveness of the prescriptions because the surrogate models of real-world data predict the fitness of those models. With this insight, we can then create predictive solutions that enable evolutionary decisions. Put the power of surrogate-based adaptive decision-making to work for your business with Cognizant Evolutionary AI. Discover and create solutions using less data than traditional neural networks, and identify relationships within your data that pinpoint the actions that achieve optimal outcomes.